In this video lesson, we are going to study the oxidation reaction of alkenes. Oxidation reaction of alkenes with cold dilute acidified manganate 7 solution and with hot concentrated acidified manganate 7 solution. The condition usually for cold dilute acidified potassium manganate 7 solution, it will be room temperature. It will be room temperature, and our product we will get in the course of this oxidation reaction, the product are alcohols. They are usually diols. Diols are usually formed. Before continuing with our topic today, please like this video and subscribe to our channel. Do not forget to hit the notification bell. Welcome back once more. As I said, we will be starting with the oxidation of alkenes using cold dilute acidified potassium manganate 7 solution. With cold dilute acidified manganate 7 solution, an example of the alkene that we are going to use, let me say, ethene. Our example will be ethene. Put it here. Ethene is our example. Ethene. Example ethene. Ethene is our example. Ethene is the example. When ethene, for instance, is reacted with cold dilute acidified potassium manganate 7 solution, the purple color of the manganate, the purple color of the acidified manganate 7 solution is decolorized. Remember, acidified potassium manganate 7 has a purple color. When a reaction now occurs, when it reacts with an alkene, for example, ethene, and a reaction occurs, this purple color is decolorized. The purple color is decolorized to colorless. The color changes from purple to colorless due to the fact that ethane 1,2-diol is formed. So when a reaction occurs, it means that when a reaction occurs, the color will definitely change. There will be decolorization of the purple color to colorless as a result of the formation of ethane 1,2-diol. Let me just write this so that you can see it better. This is ethane. We have this here. Let me say CH3, CH2, CH2. There will be the formation of a CH2, OH, and a CH2OH. Remember, as I told you, this is an oxidation reaction. It's an oxidation reaction. This square bracket, this oxygen in a square bracket, shows that or indicates that oxygen is from an oxidizing agent. This is an oxidation reaction. The oxidizing agent will help to provide the oxygen. And this is the symbol usually used in organic reaction. In organic reaction, oxidation reactions. It shows the oxygen in the square bracket is from an oxidizing agent. And our oxidizing agent here is the acidified potassium manganate 7. That provides this oxygen. And the result is what? The result is the formation of diols. So we can now say the purple color. I say the purple color of acidified potassium manganate 7 is decolorized. Is decolorized as ethane. As ethane 1,2-diol is formed. So the purple color, when this is added, will be from purple to what? Colorless. From purple to colorless. This is how the reaction is. You can see how the reaction takes place. When ethene is reacting, this is an ethene with this is ethene here. As ethene there, you'll see that ethane 1,2-diol is formed. This is water. This is oxygen from the oxidizing agent. Oxygen provided by the oxidizing agent. And ethane 1,2-diol is formed. Initially, this reaction mixture from here is purple. Then the reaction, then the product is colorless. So you see the transformation, decolorization. That's the transformation from the purple color to colorless as a result of the formation of ethane 1,2-diol. I say about it, yeah, I forgot to add water there too. Yes. So that is how. So you should know that this is another test. This is another test. It should be remembered that this is another test that can be used. That is used to differentiate between alkane and alkenes. Only alkenes will decolorize the purple color of uh, acidified potassium manganate 7. But alkane will not do that. Only alkene, if it was ethane here, it will not do. If only alkene, why only alkene? The presence of the double bond leading to this addition, forming ethane 1,2 diol is the whole thing because of the presence of the double bond there. But alkane will not do that. Alkane will not do that. So it takes us to the second condition. The first condition, as I said, cold and dilute acidified potassium manganate solution. Cold dilute acidified potassium manganate 7 solution. When reacted with an alkene, what happened? When ethene, for instance, is reacted with cold dilute acidified potassium manganate 7 solution, the purple color of the acidified manganate 7 solution is decolorized as ethane 1,2 diol is formed. As ethane 1,2 diol is formed. And I said only ethene can do that. But with under hot and concentrated solution, acidified potassium manganate, changing this the condition to hot concentrated acidified manganate 7 solution, this is what is going to happen. This is what is going to happen. When an alkene is reacted with hot and concentrated acidified potassium manganate solution, under this harsh condition, hot and concentrated acidified potassium manganate 7 solution, under this harsh condition, the double bond in the alkene will break. The double bond in the alkene will break. And the purple color is also decolorized. But the product formed in this case, since there is the rupture of the double bond in the alkene, the product formed will depend on the position of the double bond. The product formed will depend on the position of the double bond. For instance, I said, under this condition, under these harsh conditions, the double bond, the carbon double bond, in ethane breaks. The carbon double bond in ethane breaks, and the purple color is decolorized. And the purple color is decolorized. And the purple color is decolorized. But the product formed will depend on the position of the carbon-carbon bond. I said the product formed will depend on the position of the carbon double bond. So that is what happens when a thing is reacted, with hot, concentrated, acidified potassium manganate 7 solution. Under this condition, the carbon-carbon double bond in ethane, for instance, will break. Then the purple color is also decolorized. Then the product formed will depend on the position of the carbon-carbon double bond. For instance, if there are two alkyl groups at one end of the carbon-carbon double bond, that part of the molecule will give a ketone. That part of the molecule will give a ketone. For example, let me give this. Let me just write this for you to better understand. I have this molecule of, let me say, 2,3-dimethyl butane. It will give this. We have, let me say this. We have one. Yeah. It's an oxidation reaction. So what would be the product in this case? Okay, I said if there are two alkyl groups at one end of the bond, the alkyl group could be a methyl group, it could be an ethyl group at one end of the bond. That part of the molecule will give a ketone. Our example is 2,3 diethyl 2,3 dimethyl butane. 2,3 dimethyl butane. Now, two alkyl groups at one end of the bond. This is one end of the bond, and this is the other end of the bond. Okay, there are two alkyl groups here. The methyl group, there are two methyl groups here. I said under the harsh condition, what happens? The carbon-carbon double bond breaks. There's a breakage here. When there is a breakage there, oxidation is doing what? Addition of oxygen atoms to a molecule. Two oxygen atoms have been added. And what will result? The result here will be oh, sorry. That is one of the oxygen. Plus all these are what we call, these are these two molecules of acetone. So they are ketones. There are two molecules of propanone. So we said if there are two alkyl groups at one end of the bond, that part of the molecule will give a ketone. Our example is 2,3-dimethyl butane. Under this hash condition, the carbon-carbon double bond does what? Splits. It breaks. And when it breaks, the oxygen that is supplied by the oxidizing agent, which is hot, and concentrated potassium, hot and concentrated acidified potassium manganate 7 will provide this oxygen. And these two oxygen atoms will help to attach themselves to the double bond. And that is how I've explained it to you. Under this condition, there is the splitting of the bond. The two oxygen will attach themselves there. And what happens? You will have ketone that is produced. And in this case, two molecules of propanone are produced. Another condition for this, now we are done with two alkyl groups at one end of the bond. The second condition is if there is only one alkyl group and one hydrogen. If there is one alkyl group and one hydrogen at one end of the bond, that part of the molecule will give carboxylic acid. Our example is 2-methyl butane. Our example is 2-methyl butane. Why I say so that when there is only one alkyl group, the one alkyl group here is what? Is the methyl group. And one hydrogen. Under the hash condition, what happened? There is the splitting of the carbon-carbon double bond. Then addition of oxygen from the oxidizing agent. Two atoms of oxygen comes from the oxidizing agent and will attach themselves to the double bond. And when the two atoms of oxygen attach themselves to the two molecules, so because when the molecules split in the middle, and oxygen will attach itself to the two double bonds, the two products will what? The two products will be an aldehyde and a ketone. Remember, this is an oxidizing agent. With an aldehyde, it can further be oxidized. So when this aldehyde is further oxidized, it will go to what? Corresponding carboxylic acid. In this case, the product here is ethanol. This ethanol, in the presence of a good oxidizing agent, which is this acidified potassium manganate, a 7-ion solution, it oxidizes it again to what? To ethanoic acid. But the ketone will not undergo oxidation. That is why we say that part of the molecule, which is this part which is that has the methyl group and the hydrogen, that part of the molecule will give a carboxylic acid. Why? Because this part of the molecule, which is an aldehyde, in this case, which is an ethanol, will be oxidized ethanol will be oxidized to what? To the acid, the carboxylic acid, which is ethanoic acid. Oh, so that is just a simple explanation. Once more, under this harsh condition, the bond will break. Oxygen from the oxidizing agent is provided. Two molecules are produced. There is ethanol and there is propanone. This ethanol, because it's an aldehyde and because it has a hydrogen here, it will further be oxidized by this oxidizing agent to what? To its corresponding carboxylic acid, and which is what? Ethanoic acid. And this is the oxidation that follows. So this part of the molecule will give ethanoic acid. Meanwhile, this part of the molecule will remain as propanone. Now we go to the last condition. The last condition will be if there are two hydrogens at one end of the bond. If there are two, so we can summarize our equation, our former equation, that when this breaks, when there is a breakage here, this part of the molecule, which is ethanol, is finally oxidized to what? To carboxylic acid. This is it here. And this part of the molecule remains. So this is a summary of the reaction. I said the last condition is if there are two hydrogen atoms at one end of the bond, that part of the molecule will give carbon dioxide and water. For instance, here we are still using this molecule here. The molecule here is, this molecule is 2-methylpropene. Let me say this is 2-methyl. 2-methylpropene, and this is carbon dioxide, and this is this is propanone. Propanone. This is water, and this is carbon dioxide. Carbon dioxide. That is carbon dioxide. Now, as you see this, as I said, if there are two hydrogen at one end of the bond, these are two hydrogen, one hydrogen here and the other one, that part of the molecule will give carbon dioxide and water. Why do I say that that part of the molecule will give carbon dioxide and water? If we split this, what happened? For if we split this, we are going to have carbon dioxide and water. So this is how it happens. Let me show. This is a summary of what will you are expected to know. Where there is where there are two hydrogens, that section will be carbon dioxide and water, and this other section will remain. So if this splits, oxygen will be added. Oxygen from the oxidizing agent will be added, and it gives this. Let me just show you how it will go. Let me show you how it will go. Here, using this very molecule, we have this is how the whole thing can go. We will have a carbon double bond. We will have a hydrogen. You will have this. I said this is a 2-methyl propene, 2-methyl. Yeah, that is 2-methyl propene. And when oxygen is added there, oxygen is from where? From the oxidizing agent plus oxygen. Let me say I am adding 2 atoms of oxygen. I'm adding 2 atoms of oxygen. Okay, I am adding 2 atoms of oxygen under these harsh conditions. Under this harsh condition, what is happening? The bond will, the carbon-carbon double bond will break. There is a splitting of the bond. And when the bond splits, what happens? This is the product that will result. The product that will result, there are 2 products that will result. We will have a carbon, this carbon here with the 2 hydrogen, plus the other carbon, plus this other one. Oh, sorry. Plus this other one. Oh, yeah. You will have this. You will have this. And you will also have this. Oh, let me say, yeah, these are the 2 hard oxygen. Uh, these are the 2 molecules that will result from this reaction here. These are the 2 molecules that will result from this reaction here. This molecule here, this molecule will remain. It cannot be oxidized. This is a ketone. This is propanone. It cannot be further oxidized, but this molecule will undergo oxidation to carbon dioxide and water. This is what is going to happen here. Let me show you. This is the molecule. You will have this. That is the molecule. Plus what? This is the molecule. It has to undergo further oxidation, and in that case, we need to add oxygen atom to this molecule from the oxidizing agent. This is the oxygen, again, from the oxidizing agent. And what will happen there? What will eventually happen here will be what will eventually happen here will be this. That is what is going to happen. Then again, this is going to oxidize to what? This is going to be oxidized to this compound. And this compound will do what? Will still undergo further oxidation to this one. And this is the procedure that is taking place here. Let me show you. We will have this. Okay, plus what? And what will be the final product? The final product here will be what? The final product here will be what? This is carbon dioxide. The carbon dioxide is this, and this one. That's the carbon dioxide. Let me put it like this. Yeah. Yeah. Plus water. Yeah. And this. We can say this one is carbon dioxide. Let's just put it now as carbon dioxide plus water. So that is the thing. So that is what we are seeing here like that. That's the carbon dioxide and water that you are seeing. So conclusively, we are saying that that part of the molecule, that contains two hydrogen. If there are two hydrogen at one end of the bond, under this harsh condition, the carbon-carbon double bond will split. And when the carbon-carbon double bond splits, these are the products that will be formed. Using oxidation, two oxygen atoms are provided. They will attach themselves on the two double bonds. A ketone is being produced. This is a propanone that is being produced here. Now this other molecule is here. This is not the final molecule. This molecule will not remain like that because it has hydrogen there. For that purpose, this is the molecule. It will undergo further oxidation to form this. This molecule again, it will not remain like that because there is a hydrogen there. Because there is a hydrogen there, it will still undergo what? Further oxidation. And when it undergoes this oxidation, what happens? There is a COO, COO that is formed, and H2O. Indirectly, we are saying the final oxidation of this molecule will lead to carbon dioxide and water. This part of the molecule now gives us carbon dioxide and water. So that is it. So a recap of our study today. Under oxidation reaction of alkane, there are two conditions. We said cold dilute acidified potassium manganate 7 solution. Under this condition, remember the color of acidified potassium manganate 7 is purple. So under this condition, the purple color of the acidified manganate 7 solution is decolorized to colorless because there is a formation of a new product. And this product is what? The product is ethane 1,2-diol. Ethane 1,2-diol is formed. The color changes from purple to colorless. I showed it there to you. Ethane. So that is it. That is the reaction there. And I said that it should be noted that this is another test you can use to differentiate between alkanes and alkenes. And only alkenes will decolorize the purple color of acidified potassium manganate 7. Only alkene will decolorize it because with alkene a reaction will occur. They will decolorize it because a reaction will occur and the double bond will disappear. But with alkanes, they cannot decolorize it. Another condition will be hot concentrated acidified potassium manganate solution. This is a harsh condition. This is a harsh condition. I said under these harsh conditions, the carbon-carbon double bond of the alkene or ethene will break. The carbon-carbon double bond of in the alkene. Sorry. In alkene, the carbon-carbon double bond in alkene. The carbon-carbon double bond in alkene breaks and the purple color is decolorized. Then, for the products, the product formed will depend on the position of the carbon-carbon double bond. One of the conditions is that for the positioning, if there are two alkyl groups at one end of the bond, that part of the molecule will give a ketone. My example is 2,3-dimethyl-butene. I use this example. I said, with this example, under the harsh condition, this will break. The bond on the alkene will break. And when the bond on this alkene breaks, okay, oxygen from the oxidizing agent will be provided. And these oxygen atoms will be bonded to the molecule. Now, when it breaks, two of them are formed. Oxygen will attach itself here and here. And the two products will be what? They are all ketones. And they are all ketones. And these are what? They are two molecules of propanone. So we are saying under this harsh condition where the two alkyl groups at one end of the carbon-carbon double bond, the result is a ketone. Condition number 2, if there is one alkyl group and one hydrogen at one end of the bond, that part of the molecule will give a carboxylic acid. How does it happen? Here, we have, our example is 2-methyl-butane. Under this harsh condition, the carbon-carbon double bond will split. And when it split, we have oxygen provided by the oxidizing agent. It will attach itself there. And the product form will be what? We will have ethanol, and we will have ethanol and propanone. Here we have ethanol, and we have propanone. Now remember that in oxidation, ethanol can be oxidized to what? To carboxylic acid. Ethanol can be oxidized to what? That is ethanoic acid. So the ethanol produced here will undergo further oxidation to what? To ethanoic acid. So that's why we say the ethanol will undergo oxidation to what? The ethanoic acid. And we are summarizing saying here that where there is an alkyl group and a hydrogen group, an alkyl group and a hydrogen atom on one side of the molecule. After splitting, that molecule will result in what? In aldehyde, and aldehyde will result in what? Will further be oxidized to carboxylic acid, and that is how you can have a summary of this equation like this. The third condition is when there are two hydrogen at one end of the bond. If there are two hydrogen at one end of the bond, that section will give carbon dioxide and water. This is an example here, 2-methyl propene. This side of the molecule, the product there are carbon dioxide and water, and propanone remains. You might not understand how this has come to be carbon dioxide and water. I went further to show how it happened. Here we have, this is the product that is being formed. After splitting, that side of the molecule resulted in this, and the propanone. Now, this side, we are interested in this side. How does this side result in carbon dioxide and water? This side again, because of the presence of the hydrogen atoms there, they will undergo further oxidation. They will undergo further oxidation. You see the oxidation that is going on. Because of the presence of another hydrogen here, it will undergo oxidation again. And the final oxidation here will result in what? It will result in carbon dioxide and water. We therefore go back again to say, where there are two hydrogen atoms on one side of the bond, that side of the bond will give us carbon dioxide and water. Then with a molecule of propanone that will be left. We have an activity here just to show whether you have understood what we have said. This is a molecule oxidation of alkenes with hot concentrated potassium manganate 7 solution. This is the oxidation. 1. This is the alkene. This is the alkene. They are more interested in these conditions. Here, this is a ketone. The black carbon indicates that only ketone are being formed. These are the conditions. The first condition is where there are two hydrogens on one side of the molecule. One side of the bond contains two hydrogen atoms. What will be the product? Now, from what we have just discussed, you will see that there will be a splitting here. There will be a splitting here. There will be a splitting there. And when that splitting goes, it gives us what? It will give us, they will result in what we were talking the other time as carbon, hydrogen with this. And we said this will undergo further oxidation again. It will undergo further oxidation again. It will undergo further oxidation again. To what? It will undergo further oxidation again to, we will have this again. Hydrogen, OH. And this will undergo further oxidation again. To what? There will be further oxidation again to give us what? Because of the presence of the hydrogen, further oxidation. And the final product will be what? Carbon dioxide plus water. Carbon dioxide plus water. That you see how the oxidation is taking place now. So there will be the carbon dioxide and the water. So what will be our product here? There is carbon dioxide and water, and what will be our product here? Our product here, they are indicating in black. Our product here will be what? This will be our product. Our product here will be this carbon here. This is the carbon. That is the carbon. Then that is a double bond. We still have this. We don't know the compound, but it is a ketone. Now we have our oxygen. That will be the ketone. That will be the product that will be at that end. It will be a ketone. There will be a ketone here. That will be a ketone. So there is carbon dioxide here on this side. There is carbon dioxide and water. On this other black side, we will have but a ketone that will be produced there. Okay. So now let's go to the second one. The second condition is when there is one alkyl group and one hydrogen atom. There is one alkyl group and one hydrogen atom. What do we do? So if we were to balance, especially here, if we were to balance this equation here, it will be the oxidation will take place with 4. It will be 4. It will be 4 of these. That will give carbon dioxide and water plus this ketone. Now let's go to this second one here. Let's go to this second one here. I will need to wipe this. Oh, sorry. Okay, let's go to the second one where there is a carbonyl, where there is an alkyl group, where there is an alkyl group and a hydrogen atom. What happens when the bond splits? See what happened, my dear, my learners. Here, it's not visible. Let me use a visible color, please. Here, under this harsh condition, under the hot concentrated condition of acidified potassium manganate. Okay, now there will be the bond will split. When this bond splits, this section, there will what? It will be an aldehyde. This is it here. It's an aldehyde that is formed. Remember, when this bond split, it will be an aldehyde. And remember, on this other side, what? It will be still a ketone. It will be a ketone. The bond still remains like this. There is carbon. There is carbon. Yeah. Yep. That is that. The bond still remains like that. That is the bond that will be there. But remember, as I told you, it is under oxidation, a ketone. It is under oxidation. This is an aldehyde. This side of the molecule is aldehyde. And because it is undergoing oxidation, what will enable it to undergo oxidation? The presence of a hydrogen atom there. Because of the presence of the hydrogen atom, it will further be oxidized to what? To the corresponding carboxylic acid. There will be an OH here. There will be an OH here. There will be an OH that will be attached here. So that is how it is. And that is why it results in this. It results in this carboxylic acid. we don't know. Oro, we don't know. There's an alkyl group, we don't know. It could be ethyl, propyl, butyl, we don't know. So it results in a carboxylic acid. Number three, this is another molecule you have been given. Okay, this R1 and R2. Under this harsh condition, this condition says where there are two alkyl groups on that side of the molecule, on one side. When there are two alkyl groups on one side of the molecule, what happens? These are two alkyl groups. Because there are two alkyl groups there, there's no oxidation is going to take place. So when the molecule splits under the harsh condition, what happens? A ketone is formed. And what will be this? It will still be a ketone. We don't know whether it is a ketone, but the molecule will still remain like this. The molecule will remain like that, as the structure shows. But there will be an oxygen there. That will be the molecule that will be there. The molecule will remain like that. So all the molecules here, the blacks, will only be oxygen attached to them, oxygen attached to them, oxygen attached to them when there is a split, when there is a breakage of the carbon-carbon double bond. So this is just a brief revision for what we have just studied. Thank you for listening. Thank you for listening. Learners, if you have not subscribed to our channel, please subscribe and hit the notification bell. Thank you once more for watching.